Big dog. Woo, 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 woo. Big dog.
What up, everybody? Welcome to Coffee Hour. Here it is, Thursday, the beginning of May. We made it. All right, already 5 minutes, getting into the fifth month of the new year already. Boy, we done broke it in. Thanks for joining me. If you first-time viewer, we've been doing this now since the beginning of the year. I've been doing podcasts and videos for the last 20 plus years, way before it was called podcasts. It was on AOL, and I used to upload them to a repository. And in Virginia, where I'm from, that's where a lot of the AHJs would always get my recordings and stuff like that. So I've been doing it a long time, but I still love it every day to be able to come out and talk about the National Electrical Code or all things electrical, even after all these years. I'm going on nearly 40 years in the industry, and I love every minute of it. And I loved when I got my hands dirty, and I love to teach code to people in my post electrician world that is not necessarily in the trenches every day. But again, the wheels of electrical change, like new products like wire waffle, come out, but essentially electricity doesn't really change much. The electrons don't care, right? We excite them, they do their thing. You get advancements in technology, but at the end of the day, it's pretty much the same as it was for the last 30, 40 years. So, but we do get some enhancements, new technologies, and things that we get to utilize, like wire waffle, things like that. So again, if you're a young buck, you're new into the industry, you're just getting your feet wet into it, learn from those people who have experience over the years. Don't take everything you hear as gospel. Do your due diligence. Make sure you research stuff. Don't just take things at what people say. That's a problem today. People tend to just take whatever somebody says. So again, be a sponge, learn everything you can. And that's why people come to Coffee Hour, so we can talk about all types of things here in the morning. Get your day going. I've got coffee today. And when that is done, I will shift to my Diet Pepsi. I'm just saying. So, hey, thanks for joining me. Today, we're going to be talking about a simple topic. We're going to shift back into some residential. We're going to be talking about bathrooms, and we'll be talking about hallways and how a circuit can handle both in certain applications. Throw other little insights in there as we go. We'll look at the NEC. Most notably, we'll look at 210.11 and talk about different things in there, but we'll be bouncing around a little bit. But we're going to be covering that topic today. And again, Coffee Hour is Monday through Friday, so you never know what topic we're going to cover. And today, that's going to be our topic of discussion. As always, I live vicariously through all of you that join us every morning. So do me a favor, in the chat, whatever platform you're on, and we're on LinkedIn, we're on Facebook, two separate channels on Facebook, and we are on YouTube, two separate channels on YouTube. We have one that's called Coffee Hour with Paul, and then we have the Master the NEC. But we're also over on Fast Tracks Tube, as well as FastTrackSystem.com. So FastTracksTube.com and FastTrackSystem.com. You can also watch Coffee Hour live. But you can also watch it directly from the mobile app on your phone. That way you just go right to it, one click, boom, there. And you can watch it as long as you get our mobile app. Free, doesn't cost you anything. Let me show you that later, just for full disclaimer, that type of thing. And today's show is sponsored by TradeHog. If you want to have any technical question out in the field, or you want to get another set of eyes on something, you want to have take a picture of a label and then upload the label into the TradeHog. Got to be an image, okay? It's not ready to look at documents yet. It'll be like a JPEG or whatnot. Take a picture of a label in a piece of equipment and ask the TradeHog to explain it or go in more depth. You'd be surprised what it can do. That is a feature that Jeff added recently. So all those type of things are available over at tradehog.net. So check it out, tradehog.net. All right, that's the sponsor for today's show. All right, let's do some shout outs real quickly. That way we can get into today's lesson and maybe get it covered. I will go through these pretty quickly. Here we go. Paul, thanks for joining us, Paul. Glad to have you here. Tino's in the house. Tino, glad to have you here. Thomas, is in the house. Glad to have you here. Good morning. Cray Cray is in the house as usual. Cray Cray, thanks for having you here in Tennessee. Adam's in the house. Adam, I'm doing wonderful. Thank you very much. I cannot complain. I woke up this morning, so that's a good start. There you go. Adel, welcome. Thanks for joining us. Dave Scott, Dave, thanks for joining us this morning. David, our CMEC people down in Florida. Happy Thursday to you, my friend. Glad to have you here. Manny's in the house. Manny's over on our YouTube channel, sporting the code nerd green. Hey, there you go. On his way to a CEU conference with Ryan Jackson. Awesome. Ryan is an awesome educator. Tell Ryan I said hello. You'll get a lot out of Ryan. He is an amazing dude. What's up, Rob? What's up? Good morning, Rob. Christopher, good morning. Glad to have you here. Uncle Paul's in the house, that's for sure. There you go. Fernando, good morning. Glad to have you here. I see you, Jay Parker. I see that hashtag win. David says they have not repealed Ohm's law. Not yet. Still the same. Okay. They might be working on it, but they have not repealed it and removed it yet. What is up, Rob? Good morning from Iowa. Red Dog is in the house.
Woo, woo, woo. Big dog.
What's up, Red Dog? Glad to have you here. Let's see here. Rob's throwing out that hashtag Wire Waffle. Shout out to Hunter and his folks over there, Wire Waffle. These will be available on Racketeer before long, folks. And we will these are added back to the spin free wheel because we have some clamshells coming in that we can send out for you. So again, thank you to Hunter for getting those sent out to us. We're more than happy to give them away. Let's see, Fernando, nothing like good code discussion in the morning. Damn straight. Get your juices flowing here in the morning. Nothing like a good argument around the code table. Good morning, Joseph. Glad to have you here up in New Jersey. Crypto's in the house. Good morning. Glad to have you here. Kendra's in the house. Good morning. No worries, no worries. You have fast trips. Okay, good deal. You already have it. We'll spin again for you today. Charlie, what's up? Bull Shoals, Arkansas. I would say you were a neighbor, but that's back when I was in Texas. I'm no longer in Texas. What's up, Alex? Good morning. Glad to have you here. And Alex showing us what to do. Showing us to do the hashtag win, get you in on the spin. So there you go. Okay. Welcome to today's episode. Again, continue to let us know who you are, where you're from, what you got going on. You got any tests coming up? You testing anywhere? You're nervous? You got anxieties about testing? Things like that. It's all very common. So again, let us know in the shout outs in the comments. Let's get into today's lesson so we can go on and get started. Okay, so what are we going to try to learn today is after today's lesson, we're going to be able to list the equipment, grounding requirements for bathroom installations, draw a wiring diagram for the bathroom and hallway, and we're going to look at some nuances from the drawing because I want to make some observations. This is a generic drawing that we'll have today on the show, but I want to show you there's some things that you can do, and I just want to make sure I throw them out there as a learning lesson for today. We're going to be able to explain code requirements for receptacles installed in those bathrooms. Again, hopefully you know that, but again, it's always great to re-go over that, especially if anybody's got any questions about installations in bathrooms, the codes, requirements, all this kind of stuff. And then I'll give you some good general practices. Obviously, this should go without saying about placement of luminaires and shadows and all that kind of stuff, but we'll still cover it. What's up, Greg? Glad to have you here. We'll explain the receptacle outlets in hallways. And then we'll discuss fundamentals of proper lighting for bathrooms, believe it or not. What's up, Edgar? Glad to have you here. Nepo, I see you in there. Good morning. Glad to have you here. All right, so let's go on and get into it. So for us, what we're going to be looking at, we're going to designate a circuit today. We're going to talk about A14 first. So this is A from your panel, whether you label it A14 and then you give it full description. Obviously, the code requires full description of whatever the circuit would be. In this case, would be master bathroom and hallway, or guest bathroom or hallway. Very descriptive. You need to state what it is. So we're going to be talking about this. So we're going to be looking at circuit A14. We're going to be looking at it. It's a 15 amp brand circuit. So that's the first thing people go is, whoa, wait a minute. We're talking about bathrooms and you're throwing out there a 15 amp brand circuit when we know that the requirements of 210.11 say what? 210.11c3 is talking about a 20 amp circuit to the bathroom. So chill out, calm down. We're talking about the lighting and we're talking about that hallway receptacle, which is a very common application for us to put the lighting and a common adjacent hallway on that same circuit. Now, some people say, I would never do that. Well, you're never hardly ever going to use the hallway receptacle anyway, and the lighting is the lighting. Okay, so again, we're going to talk about how you might lay this out. And of course, AFCI requirements expanding throughout the NEC even more. And so again, I guess we're in a mode where we're protecting ourselves from ourselves, that type of thing. So AFCI is going to be very prominent. Same with GFCI. What's up, Miles? Good morning. Glad to have you here. Carlos, glad to have you here. All right, so let's kind of look at it. So this is our circuit. I will blow this up a little bit for everybody so we can kind of get a lay of the land. So this is what we're talking about. So we're going to be talking about this circuit right here, because this is A14. All right, so in this circuit right here, we've got coming out here, we've got the lighting in this hallway here, all right? Coming around, hitting here, hitting this receptacle. Looks like it's coming in here and coming up and going over it and hitting possibly the lighting in this bathroom over here. Okay. Of course, we have it coming over here, right? So it may be hitting something specific in this bathroom right here for the lighting, okay? And then, of course, A12 will be some other circuit that's going to be supplied probably to this combo right here, specific combo, right? That type of thing. The point of this discussion is here you see the lighting in A14 is covering this kind of this hallway area, as well as it's covering some of the lighting and receptacles in this area. And you see it's covering some of the lighting here in the bathroom, right? So that's kind of the premise of what we're talking about today. So let's see here. Now, as you see over here, this is kind of showing you this layout right here. I don't necessarily care about this arrangement here, but this right here looks like this is the A12. And of course, then this vanity light, which is in the same box, it looks like the vanity light right here is possibly getting picked up by this A14. Okay, so A14 is doing the hall. It's doing the receptacles in the hall. It's doing the lighting in the hall. And it looks like it's picking up the lighting for the vanity in this bathroom and the same in this bathroom. Okay, picking up the lighting for the vanity, that type of thing. Okay, and in this scenario right here, it looks like it, and here's the vent light combo that's doing right here. This is the A11 for this one, and this is the A12 for this heat vent light combo here. But the vanity light's getting picked up by A14, and this vanity light's getting picked up by A14, and it's picking up the hall and the receptacles. Okay, there you go. That's the lay of the land. Okay, all right, just kind of setting the tone for what we got going on today. Okay, all right. So we're talking about that A14 for the hall and the bathrooms. All right. So what's up, Angel? Glad to have you here. I am doing well, my friend. Glad to have you here this morning. All right, so proper lighting is required for shaving, combing hair, or whatnot, or if you're like me, not necessarily needed, right? Not necessarily needed, but again, for typical people, combing hair, doing your normal grooming functions, things like that. One of the things is positioning the luminaires to avoid mirroring shadows, which could obscure facial details in the mirror's reflection. A luminaire directly overhead will light the top of one's head, but will cast a shadow on the face. Luminaire should be above and forward of the person standing at the vanity. So in this case right here, placement is pretty much how you're gonna do it. So I would put, if you're gonna have vanity lights, I have vanity lights that can be on the wall. I very rarely ever would see anything over top of a vanity. I do see lighting back into the room, which is just for the general room. but typically I see lighting specific to the vanity, which is in front, casting the light onto the subject so they can look at the mirror, that type of thing. Not a code requirement for that type of placement, but that's just a common sense type of thing that all electricians, especially that are new in the trade, are thinking about placement. Now, on a residential, typically you put them wherever the customer wants. If it's a spec house, things are being done to a drawing, it'll tell you receptacle, a light over the vanity, that type of thing, and then maybe a light back in the actual bathroom area. In our case here, we have some combos right here that are out in the room. So that's a light out here, but it's also a vent and heat. So it's this exhaust vent. And same thing over here. Now, here's an interesting thought from an electrician standpoint, is when you look at this right here, obviously you're the electrician and you're going to be installing, wiring up the heat vent combo, heat vent light combo. But who does the ducting of that? That's just let me know in your comments who does that. Do you do the ducting? When I was doing the contracting on all this, I did it. So whether it was a 4-inch flex or whatever the heat light combo demanded, whether it's the metal flex, some of those with the heat in it may say they don't allow you to use a non-metallic flex. You just look at the instructions that are part of the heat vent light combo. But I was in charge as a contractor. I always did my own venting to all of my exhaust fans. Even though some people say, well, that's the utility folks. That's the HVAC guys. They'll do that. No, I always did mine. And I made sure it got vented out, that type of thing. So let me know, who does yours? Do you do them? You let somebody that does the HVAC folks do them? Even when I put just a simple exhaust fan, I always vented it out myself. It's just, I don't know, just the way I did. So that type of stuff. So again, everybody's different, different areas, different things. So anyway, so that's what we're talking about. All right, luminaire should be above and forward of the person standing at the vanity. Typically, it's over top of the vanity. I don't think I have ever put any directly above, right? I don't think I've ever put directly above the vanity. It's always been forward in the wall, that type of thing, or I have lighting back in the ceiling, that type of thing. Alex says the HVAC guys do it. Okay, again, everybody's different. It was expected of me. From all of my contractors, they knew that I was going to be the one that exhausted the fans or the combos or the whatever. Just everybody's different. All right, so this is just an example. This would be poor. If you didn't have a vanity light, this would be poor placement. Okay. Now, moving it forward right here so that it is directly over the vanity. Or in this case, you see they have some built into the actual mirror. Right? Or it could be here above it, those type of things, okay? So yeah, anybody is, my thing about it is I did not rely on the mechanical folks. When I put an exhaust fan and I just, like I said, I exhausted it. That was, I always did it. Unless it's one of those real fancy units where it has multiples and it's got this central box and one of those real fancy air exchanger, things, then I leave that to the HVAC guy, right? But if it's just a simple exhaust fan, we used to call it a fart fan, but basically exhaust fan. If I installed that fan in the ceiling, just in a typical 50 CFM exhaust fan, I just flexed it out. All right, so anyway, that's location. All right, now let's talk about it. NEC defines a bathroom. Now, good morning, Jonathan. Thanks for joining us. So, couple cycles ago, we got a definition of a bathroom. Now, on the Fast Tracks program, we ask a question in one of the competency reviews, and it's routinely gotten wrong when it talks about what defines a bathroom. And we'll ask people to tell it, and they'll say it has to have a toilet and a urinal, or a tub and a shower, or a urinal and a toilet, or a bidet and a toilet. Or a bidet in a tub. What they forget, in order to qualify, and this is important for the code, to qualify as a bathroom, it must have a sink or basin, which are the same thing. It's got to have that first, Without a doubt, it has to have at least that. And then it has to have at least one, or it could have more of the other items. So when I'm looking at something and determining whether it's a quote unquote bathroom and meet additional requirements for bathrooms, okay, most notably GFCI requirements and other type of things, then I have to understand that it is a bathroom. Now, this may seem simple, but on our Fast Tracks program, it is one of the questions that people get wrong all the time. And if you're in our program, you may have seen that question. And you have to have a sink or basin first and foremost to begin that journey to call anything a bathroom, and then kick in these other requirements for bathrooms. So it's got to have a sink or basin, okay? And then it has to have one or more, could have more of the other items. So a sink with a toilet. Right now, one of the interesting things is that you can have different segmented areas, let's say in a bathroom, but once you enter into a bathroom that has the sink and the other items, whether or not, it's my belief that whether or not we section that off and put the toilet in its own little separate room, okay, once you enter into the bathroom area, then that itself becomes the bathroom. If you have a sink, if you have any of those other items in that area that you enter into, then that is going to be what? That is going to be a bathroom, okay? All right, so people can get quite creative with how they design these systems and things like that. But again, that's the concept that I try to keep it simple, stupid when I'm trying to qualify something as a bathroom. Now, it says 210.11c3 requires bathroom receptacles to be connected to a 20 amp branch circuit, okay? So a half bath is a bathroom if it has a sink, right, and a toilet. That's a bathroom. It doesn't have to have, you're right, does not have to have a shower, does not have to have a bathtub to be considered a bathroom. So the house that I had back in McKinney was three bathrooms, 3.5 baths. And the one downstairs off the kitchen was a half bath, but it had a sink and it had a toilet. It's a bathroom. So there you go. All right. So we're talking about 210.11c3 requires bathroom receptacles to be connected to a 20 amp branch circuit. So we're not talking about the lighting. Okay. We're talking about the receptacle. Okay. The receptacle aspect of it. So if we go look at the code, this is what we're talking about right here. So here is the C3, 210.11c3 right here. Okay. It says, in addition to the number of branch circuits required by other parts of this section, which happen to be the laundry and the small appliance, those are the other ones that are part of this, quote, section, because we're in section 11, right, of 210. It says, one or more, so I can have more than one, 120 volt, 20 amp branch circuits shall be provided to supply bathrooms, receptacle outlets required by 210.52d, and any countertop and similar work surfaces receptacle outlets, okay, in that bathroom. So you could have a little makeup area that is supplied by a work surface or a countertop, okay? And it says, such circuit shall have no other outlets. Now, notice that the outlets is not just talking about like receptacle outlets, okay? There's a difference between making a statement about no other outlets versus receptacle outlets, okay? Very clear. Now, there is an exception here, and we will look at this exception in a second, okay? We will bring that exception into play. So what this means is I'm in a bathroom that I'm required to bring at least one 20 amp branch circuit to the supply receptacles that are in that bathroom. Now, that does not mean I can't bring additional circuits to that bathroom, right? And they don't have to be 20 amp. Let's say if it's for a bidet that only needs a 15 amp branch circuit, then I can install a circuit to that bidet as long as it's GFCI protected, because it's obviously in a bathroom, right? 210.8, got to meet those A requirements. But I can have another circuit in there. But to serve the receptacles that are to serve the countertop. Now, 210.52d is talking about the receptacles that are within 3 feet of the top inside edge of the basin or sink. Okay, so I have to have a receptacle within 3 feet of that basin or sink. Okay. Those are supplied by that 20 amp branch circuit. If I have an area that's next to the sink that's basically for makeup area and it's a countertop, then those receptacles also will be supplied by that 20 amp branch circuit. Now, can I have more than one? Absolutely I can. But I got to have at least the one to do that. Okay, so that's the first premise we're talking about. Okay. Now, of course, all receptacles in a bathroom, right? 210.8A1 requires all bathroom receptacles have GFCI protection. So we all know that. That's pretty much a no-brainer today. We're going in there again. So a lot of people think that GFCI, for example, is only stipulated by water. That is not true, although people hate when I say this. Most of the time it's associated in proximity, but there are other aspects of the NEC which demand GFCI protection just to demand it, like in an unfinished basement, for example. Or be honest with you, finished or unfinished basement, that type of thing. So there is requirements in the code that demand GFCI protection. And of course, there are other applications where it's just in proximity to things or within a distance to a sink or other areas in 210.8 that tell us. In this case, it says that all bathroom receptacles are going to have GFCI protection. And so we do it. We don't question it. We just do it. What's up, Ben? Glad to have you here. All right. Okay. So looking at that, this bathroom. So here's, we're dealing here. Okay. So we have here, this right here, 3 feet. So this is kind of show you a proximity scenario. Okay. Just showing you 3 feet out from the sink. We're going to have this proximity. Now I know this is a tub, but we're just trying to get an idea of proximity, how to measure proximity. Right. And so there's proximity, proximity, proximity. Okay. All right. We're not going to do a discussion. All right. Now, with understanding proximity, and this is why we wanted to shift gears here to proximity and how you measure proximity for things like luminaires that are in that bathroom. So we already established, and you got to follow along because we move quick here. We established that you have to have at least one 20 amp branch circuit, 210.11C3, serving the bathroom receptacles that serve the countertop or the ones that the receptacles in 210.52D that are within 3 feet of the top inside edge of the basin. Got it. Makes sense. They have to be GFCI protected. Got it. Makes sense. And it's okay. Now, one thing I'm going to pull back real quick and show something is I want to show this real quickly again. So, because I want to show a couple things here. So, because I want to show the exception to 210.11C3. So, see right here in this drawing, and I'll blow this up for you. See this drawing right here? See this GFCI receptacle right here? And that is circuit A22. So that's the 20 amp circuit right there, A22, right? And you notice this bathroom down here? So this receptacle right here is A23. Okay, so each bathroom is has a 20 amp branch circuit. And that is perfectly okay. Perfectly okay. But now, what if you're the electrician that says, you know what? I want to put both of these receptacles that are serving the bathroom. And again, this is your sink area. This is receptacles within 3 feet. Okay. It meets the requirements of 210.52D. Okay. It is on a 20 amp branch circuit. Okay. And it is within 3 feet of the top inside edge of the basin. Boom. Okay. So that is, meeting the requirement for where it's located. Not a problem. But what if I want to put both of these on the same circuit? Well, clearly these two circuits aren't supplying any lighting loads. Okay? They're just for these receptacles. This is for this one. This is for this one. So what does the code say I could do? Right? What does it say I could do? Well, let's look at this exception right here. Okay? It says exception. It says where the 20 amp circuit supplies a single bathroom, outlets for other equipment within the same bathroom shall be permitted to be supplied in accordance with 210.23 B1 and B2. Okay, so I'm going to show you this one. I'll show you this one first. Okay, all right. So what does that mean? Okay, right there first. Okay, so let's go back here and show you what this is talking about. Get back to the lesson here. Okay, now let's take this bathroom right here. Right? And now obviously it's going to have a hard time supplying this light heat fan combo because I'm assuming it's the heater load's going to be a situation where it's going to exceed a certain percentage of the actual circuit's load. And we follow all that in 210.23. But we're assuming that what that exception says, you know what? If I'm supplying one single bathroom, just go with me here. And let's take this heat light fan combo out of the equation. What if this was just an exhaust fan? That's it. Little old 50 CFM exhaust fan. What that exception is saying is that, you know what? I can supply the lighting. I can supply the receptacle. I could even supply the exhaust fan from that single 20 amp brand circuit, as long as it does that circuit does not leave that bathroom. So if I were to bring a circuit to this bathroom right here, focus, folks, focus. And all I picked up with that 20 amp circuit was this receptacle, this lighting, and let's say an exhaust fan, okay? Then if that's the case, as long as that circuit does not leave that bathroom, then I could pick up everything in that bathroom. You with me? Yes. So that's what the code allows for, okay? Now, getting back to the code again. Now so that's what this exception is talking about. Now, getting back to the language and what I talked about in that diagram, because we had two separate 20 amp circuits, one for the receptacle in the one and one for the receptacle in the other. Well, here's what it says. In addition, the number of branch circuits required by other parts of the section, one or more 20 amp branch circuits shall be provided to supply bathrooms, plural. Receptacle outlets, bathrooms, receptacle outlets, plural, required by 210.52D, and any countertop or similar work surface, okay, as long as it supplies no such other outlets. So, what could I do? Well, in this scenario, I could have taken A22, brought it in here and supplied this receptacle, and then I could have looped out of it and supplied this receptacle if I wanted. Receptacles, plural, okay? Because I'm not supplying any other outlets. And that would be lighting outlets. Those are example of an outlet, okay? You got to go understand the definition of outlet. It's a lighting outlet. There's a receptacle outlet is the box where you put the device in it, the point where we take power from the system. So it says I cannot supply any other outlets with it. Okay, the exception is only for that single bathroom where I can cover everything in that bathroom. Okay, so there you go. Yeah, and there is an issue when it comes to the bathroom, and again, talking about the heat, light, exhaust. Okay, so there is a limitation in there that you have to follow. All right, but let's look back here. So here we're at here. So I could actually supply this receptacle and this receptacle on that same circuit. So I could eliminate an A23 if I wanted. Okay. Now, if you want to run a separate 20 amp to each one of the receptacles in each of the bathrooms separately, go for it. That's totally up to you if that's what you want to do. Okay. There you go. That is not a problem for you to be able to do that. Okay. All right. Now the one thing about this is no, you cannot put well, I don't think you said this, but you cannot put like garage receptacles and whatnot on this circuit because remember what it said? No other outlets other than those that are required to meet 210.52D can be on that circuit. Okay, so that's it. That's all that can be on that circuit. Okay, all right. All right, we're not talking garages today, but yes, there is an allowance in the code for you to hit a garage receptacles and then hit an outdoor receptacle that may be the one that's for 210.63, where you need the receptacle within 25 feet of your outside air conditioning unit for servicing, then yes, there is an allowance inside of the code for that as well. Okay, not really today's topic, but there it is. All right, let's see if we can go back to where we were. Okay, so now let's talk about lighting in that bathroom because we pretty much beat to death everything else. So let's talk lighting. So 410, which again, you should know that 410 is dealing with luminaires, right? So 410.10D1 prohibits what can be located within 3 feet horizontally and 8 foot vertically of a bathtub rim or shower stall. Okay, so this is kind of why this picture was leading us into it. So it measures threshold, measures out 3 feet in all directions, and then from the top of that threshold up 8 feet. Okay, so you create this little zone, if you will. All right, and if it's a shower, it's from the threshold, the floor threshold of the shower up 8 feet. Okay, kind of, we're talking luminaires right now. So what is prohibited from going in that 3 foot by 8 foot space? Well, you can't have cord connected luminaires. You can't have chain, cable, or cord suspended luminaires. Can't be in that space. You can't have track lighting or any pendant type of luminaire in that space. And you can't have any ceiling suspended paddle fans in that space. Okay? All right. Now, that was 410.10D1. 410.10D2 says provides requirements for luminaires installed within the actual dimensions of the bathtub and shower. So D1 is what's prohibited from being in there, and then you've got D2, which provides requirements for what can actually be in there. Well, shall be marked suitable for damp or wet location, depending on where it's at inside the space. Luminaires subject to shower spray need to be wet location. If it's not subject to shower spray, say in the ceiling below the shower nozzle, then that would be damp location. Okay. Now, if you're my kid when he was in a shower, everything is a wet location. Okay. But typically it's where the shower spray would go, that type of thing. Right. So there is our 3 foot out. Right. And so this is what we're talking about right here. So here's your tub and it's 3 foot out and 8 feet up. So this is a code violation. This is that 3 foot, 8 foot zone. Okay. Now, interesting enough is if you pull this pendant further up here, that it's above the 8 feet, then it's not a violation. Okay. There you go. Over here, obviously not an issue. Sunken tub, again, just like a shower threshold, 3 feet out, 8 feet up. This one over here would be fine. This one over here, code violation. Okay, and this is just an example of how it would be for a sunken tub, that scenario. Now, before I forget, because I was just thinking I was going to forget, let's see here. Where are we at here? This is what we were talking about that I can't remember who said it. Oh, Charlie was talking about this right here. So remember we talked about that one circuit in a bathroom that supplies everything, right? So it supplies the lighting, but it's also supplying everything in that bathroom. And he's asking really about the exhaust fan with the heater. That's really what he's asking about. So if we were to go look at the code for that, this is what we'd be looking at. And he's looking at permissible loads on a multi-outlet, not multi-receptacle, multi-outlet. So lighting, receptacle outlets, lighting outlets, or whatnot, permissible loads, okay? And you go down, and this is one that Charlie's talking about right here, is 15 and 20 amp branch circuits. It says a 15 and 20 amp branch circuit shall be permitted to supply lighting outlets, okay? Lighting units or other utilization equipment or any combination of them, right? And shall comply with 210.23B1 and B2. Okay. All right. So there you go. Now, also there is an exception that says the small appliance branch circuits, laundry, and bathroom branch circuits we just talked about required in dwelling units by 210.11C3 in our case shall only supply the receptacle outlet specified in that section. Okay. So that is talking about the three. So only required that branch circuit, that 20 amp branch circuit that's being run to supply the requirements of C3, for example, shall only supply receptacle outlets in that section. So it seems like a direct issue with the exception that's given in 210.11C3, right? But what I wanted to focus on, Charlie, is this right here, because that you did have an exception to that, which did allow you to do everything in that bathroom. But this is what Charlie was talking about right here. So fastened in place. It says the total rating of utilization equipment fastened in place, other than luminaires, shall not exceed 50% of the branch circuit rating where lighting units, cord and plug connect to utilization equipment not fastened in place, or both are also supplied. So it doesn't give an example here, but yeah, it gives an example for it's a garbage disposer, and I don't want to give that example. It's not our lesson for today. But what we're talking about is like, that heat, light, fan, vent combo. You would have to take it, and since it's fastened in place, it can, and it's also on with the lighting in that room, for example. Then what happens is you have to take whatever the amps of it is and find out 50% of that. And again, you can't, its value or whatever the amps is of that sucker, you take the circuit, divide it in half, and it can't exceed that. So if it's a 20 amp circuit, for example, then if that heat light fan combo exceeded 10 amps, then it would be exceeding 50% of that branch circuit rating, and it couldn't go on that branch circuit. So that's probably why in our example, it's a separate circuit that's being run to it, okay? Because in our image, the receptacles for that bathroom are on a separate circuit. So it wouldn't have worked out plausible to be able to even do that type of thing, okay? Does that make sense, Charlie? That's what Charlie was referring to. Let's see here. Let's get back here. All right. So it's not typical for us to have a heat light fan combo on with the circuit that would be providing the lighting for the bathroom. And maybe it's just that would be okay. If I'm also supplying a light, chances are we're not going to exceed 50% of the circuit rating with that. So typically wouldn't be a problem, but that's going to dictate whether or not I probably run a dedicated circuit to that heat light combo scenario, that type of thing, because it does have the other lighting in that bathroom that was on it. Let's say the vanity lighting. So if that was the case, you have to be careful with that. So that's why in our drawing, they decided to run a separate circuit for that. Let's see, where are we at here? Get sidetracked here. So, all right, okay, so we're in the bathroom real quick. Okay. All right, so that's the requirement there. That's how, so again, I wanted to point out though, if this was a shower stall, okay, shower stall, then it would be measured from the threshold, okay? So it would be out 3 feet and then up 8 feet. What goes above it, if it's above that, then you're okay. So if you have a really, really, really high ceiling, then it would be okay. Also, if you're in see, we have an 8-foot ceiling, right? And you have a shower and you're measuring from the threshold, obviously it's sticking up a little bit. So it's that ceiling, even that recess that's going to go in the ceiling, that typically would be a damp location and not so much a wet, because I can't imagine you spraying the water up into the ceiling. And you're like, well, it could happen. Well, then make it a wet location. Put a ring on it, that trim ring that makes it a wet location. But typically those would be damp applications. And then inside, if you have sconces that are inside the shower area, I guess you probably say you've never seen that, but I have done large enough houses, multi-million-dollar houses, where they actually had sconces, lighting inside of the shower area, okay? And of course, they have to be rated for wet location. That's not a problem. And of course, usually their instructions are also, should go without saying, their instructions will also say that they have to be rated, they have to be GFCI protected as well. That should go without saying, right? Also, we have any questions or anything you want clarified, let me know in the comments. I'm more than happy to jump back and clarify anything. All right, let's see here. Okay. All right, let's talk about that hallway lighting. Again, we're talking A14. That was the circuit we were looking at. So we saw that it picked up some lighting in the bathroom. Okay. We saw that lighting in the bathroom wasn't picking up the heat light vent combo, because chances are, like Charlie said, it probably would violate 210.23. So again, they're like, okay, I'll run a separate circuit for that, because that heat light combo probably pulls more than 50% of the branch circuit rating. Okay, so they ran their own circuit. Gotcha. But I still picked up the lighting, the vanity lighting, and I put that on with the hall. Okay, hall lighting. So hall lighting is provided by one ceiling luminaire that is controlled with two three-way switches located at either end of the hallway. The home run is to the main panel A. Okay, I'm going to assume there's only one panel in this dwelling. Everything is marked A, so we'll just say the main panel A has been brought into the ceiling outlet box. Okay, so let's go back and look at the image again because I just want to make sure that's what they. Okay, there it is. So yep, there it is. It's brought right in here. So it's dropping out of here. So this is dropping. Looks like this is dropping down here. Now since this is going up to here, chances are this is telling me right here this is dropping straight down into here. And then this is the travelers running over to here, okay? And this is dropping the power straight down into this receptacle, and then it's feeding it straight over into this box. It's picking up this vanity light, then it's coming over here and picking up this vanity light. And the reason they're not picking up the vanity light with this circuit is, again, because of what Charlie pointed out. Chances are this heat vent light combo amps are going to exceed 50% of that branch circuit, okay? So they're not going to be able to feed the light, okay? So there you go. All right. Kind of how what's going on. All right, now talking about the hallway. It says 210.52H states hallways of 10 feet or more in length shall have at least one receptacle outlet. At least one. Okay, can you have more than one? Absolutely. But you're only required to have one. Now, you could have a hallway that's 30 feet long. Okay, as long as it's not divided or broken through a doorway, or you pass through a doorway to get from point A to point B, if it's just one long corridor, then I'm only required to have one. Now, most electricians probably will put more than one, depending on spacing or where they want. And again, you're not going to see big use out of these receptacles, right? It's basically just for convenience for your customer. They may dictate where they want another one for a vacuum cleaner or whatnot that they're working in the hall. But again, the drawings may show it somewhere else, and you just do it. But again, you don't run anything different. It's all part of the 3 VA per square foot for the loading. It's nothing else we have to do different for that type of thing. So just put receptacles where they want them. But again, the code only requires it. Now, what if my hallway is only 7 feet long? Then a receptacle outlet's not required in there, okay? Right. So this is an example of a hallway. I'll blow this up so you can see it, okay? So this is coming out of this room up here. There's a room over here. It looks like there's an entry of a room over here. There's an entry down here. It's a hallway. It's a common exit and egress and entrance to the area. You see all these entrances into rooms. This is your hallway, right? There. So you measure down the center line. Okay, so you measure from the furthest way away from the hallway, measure to the center line, measure the center line of this hallway, and you measure this way. Okay, now you could say, well, why not just measure from here? Because you have another entrance over here, so you have to look for the longest segment of the hallway. And you notice it's not going through any doorway. So in this case, it's 3'9" to here, to the center, and then is 8'9" here, okay? So obviously this is over 10 feet. So you see they put one receptacle right here. That meets the rule. That's all that it says in the code, right? When we go look at the code for that, you know, people will question this stuff all the time and say, well, I'd never do that. Code's minimum. I'm going to put one. And if it's less than 10 feet, I'm still putting one. That's fine. Do what you feel like you got to do. You do, as I tell people all the time, you do you, boo. Well, the code's a minimum. I never follow the minimum. I always exceed the minimum. Well, you do you, my friend. But here's what it says in the code. It says, in dwelling units, hallways of 10 feet or more in length shall have at least one receptacle outlet. Okay? In this subsection, as used in this subsection, the hallway length shall be considered the length along the center line of the hallways without passing through a doorway. Right? And you got a little commentary that says this requirement is intended to minimize strain or damage to cords and receptacles for dwelling unit receptacles. The requirement does not apply to common hallways of hotels, motels, apartment buildings. This is only within the dwelling unit is this applicable, okay? So if I have a multifamily building, does not apply to the corridor. This applies to the dwelling unit, okay? Inside of the dwelling unit. And the way this is read It's not specific to single family dwellings. It is dwelling units, which is a defined term in Article 100. So it may not apply to the corridors of a motel, hotel, or apartment complex where you have multiple dwelling units, but it most certainly is going to apply within the dwelling unit. And again, if it's 9 feet, 11 inches, not required to have one. 10 feet or more, got to have at least one. Can you have more than one? Absolutely. Absolutely. Now, interesting thought here is that if I did have a doorway right here, right? And so the measurement was here to here, it wouldn't require one because it's not more than 10 feet. And this is a doorway, right? And then if I started the measurement from here to here, if this wasn't more than 10 feet, then it wouldn't be required in this portion either. So I'd still have no receptacle requirement, right? It's 10 feet or more between doorways, okay? Okay, I wanted to make sure that's clear because I get people all the time say, well, I'd never do that. I'm putting one in there. You do you, boo. You do whatever you want. Charlie had a question, says the receptacle inside of a mirror that opens satisfy the receptacle code within 24 inches. That's something you're going to have to talk to your AHJ, that type of thing. But what we see is the general requirements, Charlie. If I go back and look at 210.52 generally, and let's see here, general requirements. Let me go back real quick here, Charlie. General provisions here. Hold on, let me get back here. Oops, hold on here. All right, let me get back here, Charlie, real quick. Let's go back to the NEC. Okay, so general dwelling unit receptacle outlets. Okay, so it says this section provides requirements for 125 volt, 1520 amp receptacle outlets. The receptacles required by this section shall be in addition to any receptacle that's following. Okay, so we've got all these requirements here. I just want to point this out real quick. So here you talk about general provisions, right? And you look down here and it says kitchens, family rooms, living rooms, parlors, dining, blah, 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 bedrooms, blah, blah, blah. Okay, you see what's not in there? It doesn't say anything about bathrooms. Okay, got it? Let's see here. Let's get down here. This is a wall space requirement. Again, not talking about bathrooms. Okay, this doesn't talk about bathrooms. So we get the small appliance. This is talking about kitchens, not talking about bathrooms. Okay, and you got all these here, and here's your kitchen requirements, yada, 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 right? And again, these aren't talking about bathrooms, all right? These are a countertop, islands, and nothing about a bathroom. Bathroom, right here. It says, and this is the D one, by the way. It says at least one receptacle outlet shall be installed in bathrooms within 3 feet of the outside edge of the sink. The receptacle outlet shall be located on the wall or partition that is adjacent to the sink or sink countertop, located on the countertop or installed on the side or face of the sink cabinet. Okay, so first thing we have to think about is that it tells us directly that it has to be what? On the wall, right? Or a partition. It doesn't say it can be in a cabinet. So I'm a literal guy, and we'll sit there and say that it doesn't say that. It says it can be located on the countertop or located on the side or face of a sink cabinet. Okay. In no case shall the receptacle be located more than 12 inches below the top of the sink or sink countertop. Okay. There you go. So for me personally, it tells us where it can be. So I don't think personally that can be inside of a cabinet because I think it has to be on the wall or the partition adjacent to the sink, that type of thing. So again, if I'm a literalist, again, you're going to have to let your AHJ, see if David will let you. He's an AHJ. Let's see if David will let you do that type of thing. But again, this kind of tells me where it has to be, that type of thing. So that's pretty much where I follow. Let's see here. Let's see here. Let's see here. I was trying to see if there was any additional commentary that would be worth anything in here. Nah, there's really nothing additional that's worth anything. It's just talking about some extra stuff. So anyway, let's see here. David's got a question here. What does John says? I need help with calculation portion of my journeyman's test. Then you should be in the Fast Tracks program. Okay, Fast Tracks program, we go over calculations. Okay, now you can go watch previous episodes where we talk about different things, different calculations, that type of thing. Or you can get a subscription to Fast Tracks Tube. We show calculations is there as well. But typically, our Fast Tracks program is going to do calculations for you. Show you how to do all these calculations. All right, does the receptacle that the lighted mirror plug into behind the mirror in the bathroom have to be GFCI protected? I think the requirement is all receptacles in a bathroom have to be GFCI protected, okay? Because if I go back, and great that you bring that up, David, I think that if I go back and look at the requirements on 210.8, let me get us back there real quick. Great questions, guys. Keep them coming. That's what we're here for. Okay, so we're here. I think that when it comes to GFCI protections for purposes of section, yada, yada, yada. Okay, so a listed Class A GFCI shall provide protection in accordance with 210.8A through F. Okay, all right. And let's see. So bathrooms. So all 125 volt through 250 volt receptacles installed in the following locations. And there you go. So bathroom. So for me, David, I think that doesn't really matter if it's in the bathroom. All receptacles that are in the bathroom are going to have to 15 to 20 amp receptacles. Or actually, it's not even 15 or 20 amp. It's all 125 through 250 that are in that bathroom, regardless if it's an additional receptacle within a cabinet. So that's not saying you can't have one in a cabinet. Okay, it can't meet the requirements of 210.52D, in my opinion. But if it's in the cabinet, doesn't mean I can't have one in a cabinet, but it has to be GFCI protected because it is in the bathroom. So that's a great question, because I'm sure that as clever as some of these manufacturers get in creating these luminaires with the built-in receptacles and all that, okay, you have to remember that it's still a receptacle. Now, the reason we can say this with good certainty is because, you know, David, what they did in the 2023, right? They made it clear that inside of a bathroom, that little receptacle that's inside of an exhaust fan, y'all are familiar with it, little old 50 CFM exhaust fans that have the cord and plug. So the fan goes in, it has this little plug, polarized, just two prong. It plugs into the receptacle. So they had to write that in there and say, oh, wait a minute. That does not stipulate having to have the GFCI protection, okay? Because it's part of that type of thing. So they had to add that extra stipulation in there for that, okay? But other than that, I don't see anything that says that that I'm not required to have GFCI protection in there, especially if I build something into like the mirrors or into the cabinet. Doesn't mean I can't have them, right? It's just one has to be grounded type, two, because it has to have an equipment ground, and then three, it have to make sure that it is GFCI protected, okay, type of thing. So, and then I don't think that it meets the requirement of the 3 feet unless it's a way it's on the outside so that it is on the wall or it's on a partition. It meets the requirements. The code doesn't get into that. The code lets you and the AHJ have this discussion. And I think that's another important topic that people forget is they want the NEC to define every single application. And I'm a guy that says I do not. I don't want it to define everything so that it is so rigid that I like, even though, again, it gets into where AHJs and opinions can differ, I like having the ability to have that conversation with the authority having jurisdiction and saying, hey, look, I know the code says for 210.52D that the receptacle has to be within 3 feet of top inside edge of the sink or basin. And I know it says it has to be on the wall or on a partition, or it can be on the side of the cabinet or on the cabinet. I get you, boss. Okay, so.
Woo, 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 woo. Big dog.
I get you. But if it's on the face of the cabinet and it's still within 3 feet, okay, and it's GFCI protected, then it would be technically on the wall. But then you could have some AHJs that'll draw a hard line and say, no, it says adjacent what? In a partition or on the wall or on the side of the cabinet or the. So you could have them draw that hard line. But I don't want the NEC, to be honest with you, to be so rigid in that. I like for its flexibility a little bit, that type of thing. What do we got, David? David says, so they put one in the cabinet for the owner's preference, and they added one within 3 feet of the sink edge on the other side of a double sink vanity. They can do that as well. Again, the other misconception about the receptacles for the meet the 210.52D requirement is that if I have a double vanity and I have one receptacle in the middle, then as long as that one receptacle is within 3 feet of each of the sink, it doesn't mean I have to have a separate one for each vanity. The rule just says I have to have a receptacle out within 3 feet of the top inside edge of the sink or basin. So if it's in the middle and it meets both, then I only need the one. If I have a vanity that the receptacles are on the side partitions, and so it may be within, this one on the left side may be within 3 feet, or it has to be within 3 feet of that sink and basin, top inside edge, right? But the one on the sink, the other sink, which is for your significant other, that one would be more than 3 feet from that receptacle. So that would dictate me having another one on the other side, unless I had, of course, the one in the middle. I'm not a big advocate for the one in the middle, especially if they're going to put glass up, because they probably will cover it. I'm not cutting that glass. Don't come back. And you come back and you notice that one receptacle works, and you're like, and the inspector rejects it because there's no receptacle for the other vanity. And you're like, well, I know I put one in, and now it's behind a mirror or something like that. That sucks, because I'm not cutting the mirror. You know what I'm saying? I'm just saying. Let's see here. Van said, I saw the test answer that the countertop receptacles in the kitchen shall be GFCI protected, but I couldn't find it in the NEC. I'm not sure what you mean. In the NEC, we're not doing kitchens today, okay? But if you're in the 2023, again, it's important to know which code cycle you're in, okay? So the GFCI requirement right here is kitchens, okay? So this was for their GFCI requirement. So all 125 volt through 250 volt receptacles in kitchens, okay? So no longer is it just the kitchens serving the countertop, okay? So there's that one, right? And then in 210.12, I'll show you. Again, this is 2023 code, okay? Here is the requirement here, all right? And what it says down here is the locations. We'll go down to locations right here in dwellings. See the little N right here? Kind of change the way it looks here. It says all 120 volt single phase. Now remember, here's a little tip. When you see 120, it's talking about the branch circuit. When you see 125, for example, like in 210.8a, it's talking about the receptacles, okay? You understand? So now if you're in 210.12b for the AFCI, it says all 120 volt circuits. So see kitchen. So all, it's the lighting. That would be all 10, 15, or 20 amps. And again, you're not going to find any 10, by the way. It's just don't get me started on that 10 amp circuit. Just don't even get me started today. Nobody take me down that rabbit hole. So any 15 or 20 amp branch circuit that's in a kitchen, then it's going to, as far as receptacles are concerned, 210.8a is going to require GFCI protection. Any branch circuit that's supplying the kitchen that is a 120 volt branch circuit is going to require AFCI protection, okay? And there it is right there, 210.12b1, right there. It just says kitchen in general. It doesn't say nothing about the countertop only, whatever, that type of thing, okay? I don't get into IECC. I'm an NEC guy. If you have any requirements for the International Energy Code, follow them. If your state adopts them, I don't do energy codes. All right. I'm an NEC guy. Okay. All right. So that's our hallway requirements, right? All right. There you go. Now, equipment grounding. With few exceptions, okay? With few exceptions, yeah. Paul says, now the only 10 amp branch circuit that I would ever see ever in a bathroom. Obviously, it couldn't serve receptacles because you're not allowed for a 10 amp circuit. The only thing I would ever see a 10 amp, if you did, was to do luminaires, because we know that it has a fixed wattage, fixed load. You size it to the maximum wattage. Even if they could underlamp it, you do that. Jonathan, don't even want to go there, Jonathan. I'm going to ban you. I'm going to kick you off. All right. So at the end of the day, you know, when you just, let me say this, Jonathan. How many of you electricians want to carry so many sizes of wire on your job site? Do you want to carry a non-metallic sheet cable that's good for 10 amps, one that's good for 15 amps, one that's good for 20 amps, one that's good for 30 amps? Or would you rather carry a conductor that's good for 15 amps, can cover lighting and receptacles, and you don't have to worry about the mistakes? I'm just saying, I'll leave it right there, okay? I'll just leave it right there and walk away from that topic. All right? I'm an electrician, dude. I don't want 5 different coils of freaking wire to do the normal general application stuff. It's stupid. I'm going to get in trouble. I'm going to get in trouble. You're going to get me in trouble, Jonathan. All right? All right, so with few exceptions, fixed and fastened in place electrical equipment with exposed non-current carrying metal parts, that's the frame, the metal housings, things like that, that could become energized must be grounded, including appliances, furnaces, air conditioning, heat pumps, etc. You're going to run an equipment ground with it. Okay. Now, AJ says make it all. I'm not for that either, AJ. Although I do, it's more copper, so I make money when you buy bigger, you know, but I am a believer that 15 amp circuits are fine. As long as you're loading it to 15 amps or you're protecting it 15 amps, I don't have any problem. I still today, if I were to go out tomorrow, and I will be doing some videos this summer of me out there with the tools on, I will still run 15 amp circuits all day of the week because I'm going to size them right and I'm going to load them. You know, and I'm going to know what I'm putting on it. And so there's certain things that, you know, plus if you've ever done houses, and I have done houses with 12 gauge and everything for the where it could have been 15 or 20 and I ran 20, dude, it's just a beast. So I prefer the relaxation of being able to do 14 gauge on some of the aspects of it and not have to deal with the 12 everywhere. You know what I'm saying? I'm just saying. Okay. How many of you do the kitchen and you're doing everything else and everything's going great and you're like, oh shit, you know?
Woo, 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 woo.
Now I got to do the kitchen, right? You know what I'm saying? And then you're like, oh, the agony. I know. I'm exaggerating it, but you get what I'm saying. All right, so double insulated in lieu of grounding. That is where you have a 3-wire cord connected appliance that are grounded by the grounded conductor within the cord itself, okay? So there is appliances that you may be using that the cord, typically a 3-prong cord, but the receptacles that you install for appliances, you're typically going to have an equipment grounded conductor run for that anyway, so you don't really have to worry too much about that. Immersion detection circuit interrupters, special attachment plug caps. This is kind of what you see on some of your hair dryers. They'll have what's called immersion detection circuit interrupters. Not necessarily a requirement in the code, but some appliances that you may get or some little utilization equipments may have these integral, okay? Integral to the actual utilization equipment, and it's built into the attachment plug cap. And that's what it's designed for, immersion, that type of thing. I have seen some videos online, guys, of a guy who takes a hairdryer and throws it in a sink in a bathroom, and he goes, see, the GFCI doesn't work if it doesn't have an equipment ground. And what the guy doesn't realize is that in those scenarios, one is if it's a GFCI, the GFCI is looking for the imbalance. Okay? So GFCIs work even without an equipment ground. It's looking for leakage current to go outside of its normal intended path, which would run it through what's called a toroidal coil. That coil, if you run the circuits through it, it doesn't detect any magnetic field that expands and collapses or any current that can change that magnetic field because not all of it that's going in is coming back. So it's leaking another path. You get what I'm saying? So the coil just sits there and everything works good. The GFCI is like, okay, happy, happy. But the moment that current travels in a different path, now the GFCI senses this and it trips it off, Okay, that type of scenario. So he was like, well, I threw it in the sink and nothing happened. That's because the sink was porcelain. The water was, there was no return path for it to trip. So the concept is, if it's GFCI protected, and again, GFCIs are not fail safe, okay? They're not. But if you drop that in there and you have some other component that may be grounded or bonded at some point, or maybe if it's even you that are on a tile floor that's connected to something or whatever, and you happen to touch it, because you're the one we're worried about, right? You, not the hairdryer, okay? Eventually that will fail, because once the internal components, then you get a short circuit and it eventually will fail. Okay, it will blow. But it could take some time depending on how the parts are isolated, encapsulated, or whatnot. So we're really worried about you touching it and you providing that path for current to flow. That's what we're trying to do. But if you take a GFCI, for example, and you touch between a hot and a neutral, don't do that, by the way. Don't do that, disclaimer.
Woo, 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 woo. Big dog.
Then the GFCI will only treat you like a load, just like it did that hairdryer that's in the sink. But if you have what's called immersion detection circuit interrupters, then there is a high probability that it will trigger it and will trip it off, okay? Tito said he should have put his hand in there. Well, that would have been a true experiment. You're saying, Tino is saying, this is not me now, this is Tino saying, and excuse me, Tino, if I'm I guess, transmitting your thought process here, he should have been barefoot, standing on a copper plate, connected to the copper pipe, while that hairdryer was in the sink, and stuck his hand in there. Then that would have been a proper representation of that. Is that what you're saying, Tino? I don't want to put words in your mouth, my friend, but
that seems like what Tino is saying today. Not me, not Paul Abernathy, but Tino. Just Tino!
Okay, I'm just saying. All right? So anyway, videos like that on social media, just crap. Now, over time, that would have. So the reason you have circuits, folks, that allow you to put a GFCI protection on something that doesn't have an equipment ground doesn't make it better. It just is a little safer, and it's better than nothing. So that if somebody comes in contact with it, there is a higher probability that current may travel on a path that it wasn't intended and allow the GFCI to actually function, okay? So, and if you're you're not grounded or you're not bonded and you touch it, then you're not going to feel anything. If you're at the same potential, you're not going to feel a thing. It's when you're at a difference of potential is when you're going to get shocked, that type of thing. So, again, GFCIs are not the holy grail, but there's many occasions where that can be a safe solution for whatever situation you currently have. You with me? It's not perfect, but we do have allowances in the code for that, okay? Switches that are located in wet locations, do not install switches in wet locations unless they're part of the listed tub or shower assembly. So again, you do have certain types of shower assemblies that I have seen some that the switches are actually integral into the shower assembly. It's kind of neat, but again, they have all their own provisions that are made up for this, and they have special wiring box on the back and all this stuff. So, but again, other than that, that's the precautions that the manufacturers have taken care of. It's not something that you would normally run into, okay? All right, so we won't look at reflection, all right? So let's get back to me. And let's kind of talk about all these things that we talked about and kind of do a real quick recap. Okay, so I can have a 20 amp branch circuit that's required by 210.11c3, serves the receptacles that serve within 3 feet of the basin, as well as any receptacles that would serve a countertop or workspace in a bathroom. That would be on the 20 amp branch circuit that's required by 210.11c3. Can I have more than one? Yes. Got to have at least one? Got to have at least one. Can I have other receptacles in that bathroom? Absolutely. Do they have to be 20 ampere rated? No, they don't. Can I have a 15 amp receptacle in a bathroom, let's say for a bidet? Sure, you can. Okay. Does it have to be GFCI protected? Absolutely, it has to be. Now, can I put all of the lighting and the receptacle, everything on the 20 amp branch circuit that's required by 210.11? Yes, under the exception, as long as that circuit does not leave that bathroom. Okay. Can I put a heat light vent combo on that circuit? No. If there's lighting on it as well as that utilization equipment, which is that heat light vent combo, then if I did that, then the rules in 210.23 said that, well, if that's the case and it's connected to the lighting circuit, then guess what? Then you can't exceed 50%, because that's fastened in place heat van light combo. You can't exceed 50% of the circuit's rating. So if it's a 20 amp circuit, obviously it's what we're talking about, then I couldn't exceed 10 amps. Well, if the heat light combo exceeded 10 amps, then that would be a problem. It couldn't be on that circuit. So that is why in our example, it ran a separate branch circuit for that heat light vent combo. Okay, that's why they did it there. What else? Could I run that branch circuit for the receptacle in that bathroom and loop it to another bathroom? Absolutely, as long as only thing that it did is those receptacle outlets. That's it. No lighting or nothing. Then I could loop my bathroom receptacle outlets. Could I run separate home runs to all those if I want? Absolutely, I can. Okay? Not a problem for that. In kitchens, what we covered. Kitchens, the receptacles in the kitchen, GFCI requirement, and all 120 volt branch circuits in kitchens are required to also be AFCI protected. We'll talk about AFCI on an upcoming episode. Get into all the AFCIs and the requirements and everything like that. Hallways. Any hallway that's not broken by doorways that are 10 feet or more requires at least one receptacle. No separate branch circuit for that. That's covered in the 3 VA per square foot. You just find the circuit that you want to add to it, typically the lighting circuit or general use receptacle circuit. Okay, you're not going to get that hallway on the bathroom circuit, okay, when it comes to the receptacles. Remember, no other outlets on that circuit. But the lighting's okay. It's fair game. Let's see here. Oh, another question people ask. If I have a bathroom right next to a master bedroom, can I supply the lighting in the master bedroom? I mean, the lighting in the bathroom from the master bedroom? Absolutely, you can. The general rules for a branch circuit is I can control lighting and receptacle. Okay? But I cannot put what? The bedroom lighting on with anything that might be part of that bathroom branch 20 amp branch circuit. I couldn't do that, right? Couldn't do that type of stuff. What else? Oh, receptacles. You have to have a receptacle. 210.52D requires a receptacle to be within 3 feet of the top inside edge of the basin. If I have a bathroom with multiple basins, one receptacle outlet will work as long as it is within 3 feet of both of the basins. If it is not, then I will put in additional receptacle outlets to make sure that I have a receptacle within 3 feet of either basin. Okay. What else did we learn? We learned that a bathroom has to have a sink or basin first. Has to have that first. Then, in order to qualify as a bathroom, it has to have something else, okay? I have to have at least a toilet as well as a basin, or at least a tub as well as a basement, okay? That type of thing, okay? All that type of stuff. So I have to have the elements, at least 2 elements there, to be considered a bathroom, okay? Now, why is this important when it comes to the bathroom definition? Well, what if I had this unique, and I had this happen, where you go into a common corridor, and then you have a separate entry over into an area that has a shower and a toilet, and then has another separate area, it's total separate entrance that has a sink and maybe I think it was a sink and a tub. So the other one had a toilet and a shower, and then it has total separate entrance. And in that area, it had a sink and I think it was a sink and a shower, a sink and a tub. So one had a toilet and a shower, and the other one was a sink and a tub. Okay, the only one that qualified as a bathroom was the room that had the sink and the tub. The other one had the toilet and the shower, and it did not qualify as a bathroom, right? But we go back and look at 210.8a and say, well, how did you address that, Paul? Well, this is your dwelling unit right here. And it says, okay, it's not a bathroom because it didn't meet the definition of a bathroom, right? But we go down here, and what is this one? Bathtubs and shower stalls. It says where receptacles are installed within 6 feet of the outside edge of the bathtub or shower stall, then those receptacles have to be GFCI protected. So in this case, that receptacle, which was in that area, okay, it wasn't for a bidet, by the way, it was just in that area. It was within 6 feet of the shower stall, so it's going to get GFCI protected, so it covers you there. But if it was more than 6 feet and that wasn't a bathroom and it had the separate entry into it, separate doorway and everything, then AHJs could look at that and say, well, I don't consider that a bathroom. I consider the other one a bathroom, but I don't consider that one a bathroom. That type of thing. And then there's some AHJs, listen to me here. This is important. Some AHJs may consider the threshold that you walked into, the common area, which then branched off to the left and to the right to 2 separate areas. They may consider all of that a bathroom. Why do I say it this way? Because the NEC is not designed to get that complicated. It's not complicated. It's not designed to be the holy grail for everything. It means that you have to work with the AHJ. So you have to present your argument and say, well, Mr. Inspector, this area has a doorway. It's separated off. It's a total separate area. This area is a common area that we go into. Okay, it's not a foyer. Obviously, it's not designed like a foyer, but it is still could be considered a hallway because it has separate rooms that enter into it. So then it may require a receptacle in there if it's a hallway and it's more than 10 feet. If it's not more than 10 feet, then it wouldn't require it. No different than we're not required to have any receptacles in a mud room, okay? Unless your AHJ says that it's not a mud room, okay? They say it's something else. And again, you might not like the fact that the AHJs can make these calls, but I do. Because and not all AHJs are going to be open to things, but the majority of the ones that I've been training them for years is that I tell an AHJ, we have to start using a little common sense. We have to open our mind and realize that if I entered into a common area and it had a doorway and I entered into this long common area and then I had a separate doorway with a door that went to this area, which had a toilet and a shower, then I had a separate doorway on this side, okay, like a Jack and Jill thing here. And over on the right is where my sink and where my tub is. There's no point in me having to have the same requirements for a bathroom on the left side as I do on the right because that is a bathroom. This over here is not a bathroom, okay? But the moment that we threw that shower in there, then if I did install a receptacle outlet, if it's within 6 feet of it, then that's going to kick my GFCI. Remember, 210.8a is talking about receptacles in GFCI requirement, okay? Let's see here. Tino says, what if the outlet is in the hall and back to back of the bathroom, shower, or sink? Okay, so it would not matter because it's not about the cavity. You with me? Let me see if I can show a picture of this, just kind of give you an example of what. Okay, so right here, see this one right here? See this receptacle is on the back side of this area? It has nothing to do with the wiring in this wall. So again, this would not be required to be GFCI protected. Well, what is interesting to your comment is that now in the code, this doorway cannot break the measurement, right? It used to be that the doorway would break the measurement, okay? And I'll show you that in 210.8. But see this receptacle right here, and this is the sink? Well, what if I happen to have a receptacle that's just right around this wall right here where this S3 is, right? What if I had a receptacle just right here? So now let's go look and see how the code would do that. All right, so there I go look at 210.8 right here. Okay, and I'm looking at the general requirement. Okay, and it says for the purpose of this section, it says the distance from receptacles shall be measured as the shortest path that the power cord, again, it doesn't follow the contour, shortest path. Pull a piece of wire from point A to point B tautly, okay, tight. That is your shortest path, okay? So the purpose of this section to measurement from the receptacle is measured from the shortest path of the power supply cord connected to the receptacle would follow without piercing a floor, wall, ceiling, or fixed barrier. Doesn't say doorway anymore. Okay? So, in our case, we're looking at this one. 8, sink. This is a generic sink. So it says, where receptacles are installed within 6 feet from the top inside edge of the bowl or the sink, it's going to require GFCI protection. So great question. So if this receptacle right here happened to be located right here near the end, whether this is a doorway or not, a couple cycles ago, this would have been breaking the measurement. Doesn't work like that anymore. So basically, if this receptacle is right here where this S3 was, and as the crow flies, direct path a cord would take, because remember, a cord's not going to run along the contour. It's going to go straight from here around and to the sink. If this receptacle was right here and it's within 6 feet of this sink, guess what? GFCI protection, even though it's not even in the bathroom. And that comes in very common where you have a master bathroom and you have a bedroom and you have that doorway now and you have a sink. If they place a receptacle just inside the bedroom, okay, then it is within 6 feet of the top inside edge of that sink. Then guess what? I should say within 6 feet. But yeah, from the top inside of that bowl, then it's going to require GFCI protection. Whereas normally in that bedroom, it would not. So if you don't intend for that to take place, now both still require AFCI protection. But if you intend to not put that receptacle, if you were to stick it here, then what you need to do is do like this guy did. You need to move it further down the wall, okay, so that it is further than 6 feet. But it has nothing to do with in the wall. Okay, so just because this receptacle is on the other side of this wall, that wall is you're going to have what's called wet board up. You're going to have insulation, maybe not. It's interior wall. You're going to have sheetrock, gypsum. That's fine. And we don't care about what's in the wall. Inside the wall doesn't make that a wet location, by the way. Okay. All right. So again, hopefully that answered that question. Let's see here. Fernando says some houses have a bathroom and a bedroom all in one room. Also, yeah, that if you have like an efficiency, that's important. So if you have a bedroom and it has all the elements, I think that would be a pretty crappy design, but an efficiency might. But I would never have my bathroom inside of my bedroom. But at the end of the day, we can call something a bedroom, but if it has a sink and a toilet in there, then your AHJ is going to look at that and say, dude, you just have a big bathroom that you can sleep in, or you have a big bedroom that you can crap in. However they want to look at it, I would invoke both of the requirements, that type of thing. Okay? All right? All right, guys, let's get to some giveaways real quick. I can't cover everything on here. If you got any additional questions, please go to paulabernathy.com and submit them. I'm more than happy to take them up. But let's go on and get to some giveaways here so we can get something going.
Woo, 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 woo. Big dog.
All right, let's do this. All right. So conductor length requirements. So let's see here. This is Outdoor Man. Let's see here. Alex. And you're for conductor length card. Wait a minute. As MSUD, I'll answer that question in a minute. Let's see. Conductor sizing. So don't go anywhere. Okay. So that's there. Conductor length. Let's do another one real quick. French, okay, which is fitting that you would get registered for an NFC promo card because you promote us on all social media so much and you got all of our swag. This makes sense. Everybody should vote and say Adam should get one of these anyway without a drawing. What do you think? If I get everybody says, hell yeah, Adam is a promo guy, then you know what? You won't have to draw. Adam will just send you one of those promo cards. How about that? Let's get some response from people. It's like, hell yeah, Adam's a promo guy. All right. Okay. So let me get back real quick to this question here. Okay. So EMSD, am I saying that right? All right. So let's go look real quick at the NEC. And let's go back here first. Let's go all the way back to definitions. And let's see if I can get down here. Bear with me here. Bear with me. I got to dig through all of this. Bear with me. Oops, hold on. Let's see here. Am I showing you everything here? Let me see real quick. Let's see here. I'm going to look real quick, see if there's anything here. Oh, wait a minute. Hold on. Oops. Oh, hold on. Let me go to, why am I clicking on that? Hold on a second. It won't let me get back here. Bear with me. Definitions are so long. There we go. All right, let's go to 210.52 real quick. Okay. All right. So let's get into spacing here real quick. Okay. All right, here we go. Okay, FOIR. So there are the FOIR requirements, and that's kind of what you was asking. Is it a laundry room? First of all, let me put it to you this way. This is important. When somebody's laying out a blueprint and an engineer's designing it, and they put on their FOIR, then immediately there's FOIR requirements. If they put on there a dog room, for example, or they put on there let's see, what are we going to call it? Let's see, a mud room. Now, if they put a mud room in there and then of course, if it's for like floor drain and there's water and it becomes a wet location or damp location, then of course, then we have all the rules in 210.88 we've got to do anyway, because again, it's, receptacles installed in there, that it's going to be a wet location, and we got all those rules, okay, if we put any in there, okay? But your question is like, let's look at what the FOIR is. So here at 210.52i, it says a FOIR. It says a FOIR that is not part of a hallway. Okay. Now, a hallway typically is going to be a place that we have transitions. Multiple rooms would come into it. Okay. More than one or opposite ending. Okay. So we have a room that you have an entry into it. So it's not connecting rooms, it's an entry. And again, this is my view of it. You do what you want to do. But coming into it, I only have one exit out of it. Okay, so I don't necessarily call that a hallway. Okay, but a FOIR that is not part of a hallway. So if there's any question about whether or not a FOIR into a building, like you first come into a building or come into the residence where you have this grand entrance and it exits off into other rooms, that is going to be a hallway unless it's of a certain size, and then it's going to kick it into a FOIR requirement, okay? Now, before that, we just had to treat it as a hallway and say, okay, down the center line, if it was more than 10 feet, I gotta have at least one receptacle. But then what happened when it became of a certain size, then we had additional requirements. Now, whether or not you want to call a mud room a FOIR when it clearly stated on the drawings that it's a mud room, that's between you, your AHJ, and the designer. I always tell my engineers, even when they do a spec or even learn, be very descriptive on the rooms because they matter. Why does that matter? Okay, well, I could have an electrical closet that is going to be different than somebody just labeling a closet, or it even be construed as a closed closet. All these things matter. If it's an electrical closet, then I can have certain things like panel boards and stuff in that I can't have in a closed closet. I can't have overcurrent devices in a closed closet, okay? So again, labeling is important. And again, this also may give you ability to go back to a design professional if you get in a bind and say, you know what, I need you to submit a submittal, right? A submittal that changes the name of this room on the drawing. Now, again, whether or not you and the AHJ can agree or not, it's up to y'all. I mean, that's between y'all. I mean, everybody would like the code to be, first thing I'll tell you is the NEC is not an instruction document. It's not an installation guide. It's just giving you information that you can use to get from point A to point B and keep it as a minimum safety standard. The AHJ is incumbent on them to interpret things. You may agree or disagree with them, but y'all should come to a meeting of the minds and use a little common sense in an application. If a hazard's there, then prepare for the hazard. Okay. If you can agree that there is a hazard or a hazard could take place or something that could be safer, then that's an agreement y'all have. Okay. That type of thing. Okay. So now, without that said, most of the mud rooms that I've ever been involved in that come off of like a back door or something like that, probably going to have multiple receptacles in there. They're not necessarily meeting the spacing requirement, and I'll show you that in a minute. But nothing says you can't have receptacles in there. We're not saying that. Okay? I'm not saying you not to put receptacles in there. Okay? What I'm saying is they don't have to meet the spacing requirements, and I'll show you why here in a second. All right, let's go back to okay, so wait a minute. Let me get back to where NEC. Okay, so here's what it said for foyer. It says foyers are not part of a hallway. So again, as accords with 210.52H, okay, so they're not a hallway, or you're trying to say they're not a hallway. Why? Because they have an area that is greater than 60 square feet, shall have receptacles located in each wall space that is 3 feet or more in width, doorways, door side windows that extend to the floor, and similar openings shall not be considered wall space. Okay, so any doorway is a break in the wall space. Okay, any door side windows that are on the side of the doors, that's not, they go from the floor, extend from the floor. Those are not considered have anything to do with wall space. It's only the actual wall space. And any of that wall space that is 3 feet or more, then it's going to require you to put a receptacle in it. Okay, so that's how you would address the foyers. Okay. And let's see here. Okay, notice this. Okay, I might not have to go there. If this is for you, I might say, so foyers are not included in the living spaces that are covered in 210.52A, even though they may have comparable dimensions in some cases. This requirement provides for receptacle outlets in these spaces to accommodate lamps and other utilization equipment. The primary objective of the requirement covering any of the dwelling area included in 210.52 is to minimize the need for extension cords that supply utilization equipment. So, to answer your question, if you go look at 210.8 right here, right, you're going to see that it doesn't say anything in there about foyers in here, okay? Now, it also doesn't say anything in here about a mudroom. But you see it says similar rooms, but a mudroom is not similar to a library. It's not similar to a sunroom. It's not similar to a bedroom. I don't think it's similar to a recreation room, right? It's not similar to a living room. So if that's the case, these provisions don't require the spacing provisions. So that's why I'm telling you a mudroom is not similar to any of those things. But if you want to put extra ones in there, have at it. But it's not a foyer, okay? That type of scenario, okay? But if you want to say, oh, wait a minute, I think it is a foyer. Okay, well, if that's the case, if it is, it's obviously not a hallway. It's a room, okay? And then, of course, you can go look at the definitions of room in the International Building Code, find out. I don't remember what it is. I don't know if it's 70 square feet or 90 square feet. 10 by 7 would constitute a room, okay? It's not primary function is to transition between rooms, so it's not a hallway. It's not a foyer to me. One is it doesn't meet the size requirements for foyer, or maybe it does, but it's not an entry that leads off into multiple rooms, so I'm not going to qualify it as a foyer. But if you want to call it a foyer, that's fine. You just have to make sure that if you do call it a foyer, that you put at least a receptacle on every 3-foot section of wall. And if I have a 3-foot section here and in a doorway, I put one in that 3-foot section, I have another 3-foot section. I put one in there. And if I have another 3 foot, I put one in there. Doesn't matter where I put it in that 3 foot, right? I just put it in that wall and be done with it. That's a choice you're going to have to make. You can get away from that. I don't know of any AHJ that calls an entry into a mudroom a foyer. Okay, I call a foyer an entry into the main entrance, and it's just me, where it opens up into multiple rooms. Okay, that type of thing. But to each his own. Okay, but what is important is you don't treat the mudroom the same way you would treat a bedroom or a living room or a den or a library, whereas you meet the 6 foot, 12 foot rule. Does that make sense? Okay, hopefully that made sense. Let's get back to giving a few more things away and I'll let you go. And Adam, I am sending you the NFC card. Do me a favor, Adam. I'm sure I probably already have it, but send me an email again with your email address. Because I gave all the other stuff to Jeff. So I don't have all that. That's good. All right. Hold on.
Woo, 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 woo. Big dog.
All right. Big dog. Okay. We're going to have you down for trade hog drawing. All right, I'm running over today, folks, a lot. So let me let you folks go. Thank you, everybody, for the giveaways. Everybody for joining me. I appreciate you all for being here. Let me take you back to the main screen. Hopefully you got something out of the day. There's a lot of stuff to talk about. Bathroom circuits, things to be aware of. We talked about spacing, placement. We even went down rabbit holes of AFCI, all that type of stuff. Join me tomorrow on Friday, where we will go down another lesson and answer any code questions you may have. And if you think of any, bring them to class tomorrow. We will see you. God bless. Tell your friends about it. We'll see you on the next episode of Coffee Hour. Till next time, take care.
Yeah.